My name's Hazim Gaber. Today we're going to look at telephony. We've previously talked about an introduction to analog signals. So recall from last time that telephones carry an analog signal of around 300 to 3000 hertz. So remember we have three components to our telephone system. We have the source, and we have the cable, and we have the recipient. Now, if we think about this more complicated, we actually have two people. So we have our central office, which connects all of our telephones. So technically, in every phone conversation, the central office, so if this guy is the source and this guy is the recipient, this guy on the left here is making a phone call with this guy on the right. He's actually the source one way, and he's a recipient the other way. So we have another transmission here. But in reality, neither of them are talking. So back in the day, in the 50s or whatever, the central office would physically connect. When you want to make a phone call, they would physically connect the cable in the office. So your line was connected to his line, and this became a circuit switched network. And then when you hung up, they disconnected this line. So now, of course, there's switching equipment in the offices. And so now the central office is actually a source and recipient of every phone call. So an analog phone system uses two wires, one pair, and they're Cat3, so they got twists or whatever. And from your phone, you're sending data on one line, and it's passing to the phone, and the phone sending data on the other line. And so telephone systems involve a lot of experimentation to get the right frequency, and which is why we settled at 300 to 3000 hertz. And we also settled at 600 ohms for the resistance, because both phones need to have the same resistance or a very small difference. We also use 900 ohms in the central office within the switching system. And we can do that because if we use a 22 AWG and a 26 AWG cable. And I mentioned echo. We do have echo sometimes in the telephone system. So the reason we have echo is because our telephone conversation travels at 150,000 kilometers per second, half the speed of light. So a very long distance phone call, which is maybe say 6,000 kilometers, will have delay of 0.04 seconds. Or on a satellite, the delay might be 0.25 seconds. So we do have some distortion in the signal, and part of that distortion happens because, assuming we have in my telephone system, I have a cable, and I say I have a long distance. Let's say this is 100 kilometers between the two phones. We're going to have some distortions. Remember, we're transmitting on a sinusoidal frequency, and what tends to happen is we have a phase shift. And so this phase shift can distort the signal. And part of it is due to the resistance of the wire. So the way we can reduce this shift is we increase the frequency, because the higher the frequency, the faster the signal is transmitted. And we know that from the formula V equals F lambda. So if we keep the wavelength the same and we increase the frequency, we're also increasing the velocity. So remember I said 300 hertz, our frequency is about 37,000 kilometers, or velocity is 37,000 kilometers per second. At 3,000 hertz, about 125,000 kilometers per second. So, in order to help with that, we can add a loading coil. I digress. So, if I'm talking, my voice only has certain frequencies that my vocal cords can generate. and I think they're 30 to 50 kilohertz or whatever. Should say they're 50 hertz to 12 kilohertz. So if I got noise that's less than 50 hertz or greater than 12 kilohertz, I should be able to cut any sound wave that's generating a frequency outside that range. And I can do that with a loading coil. So the thing of it is a filter. It's filtering all the signals on my line that we know for a fact are not human voice. And if we do that, we can have a much better signal. And so we add these loading coils every 1.37 kilometers or 1.83 kilometers along our line. The problem with these coils, though, is they cause delay because our data has to pass through and get filtered and keep going. So there's a delay, and then we also have a distortion in the frequency. So obviously we can't transmit high frequencies when we have a coil. And that pretty much covers analog phones. Now we're going to go into digital or internet protocol ideas next. So an IP system uses what we call a packet switch network. And we have IP telephones. An IP telephone is basically a computer. So it does not use an analog. And it does not use an analog one pair. Two wire. It has to use Ethernet or whatever. We'll go into that in more detail. But it can be a phone or it can be a computer or maybe even a cell phone app. And so when we think about it, we're going to kind of cut into our office design. But we have something called Ethernet pass-through. And we'll cover this in more detail later. But when you're designing an office, you have your network. You may have analog port and data port. For your phone. And the data for your PC. Or you might have one data port for phone, and then your phone connects to your computer. So this part goes to a phone system, and this part goes to your network. This goes to your network. Or you might have two datas. One data for your phone, one data for your computer. Or you might have Wi-Fi. So computer and phone are on the Wi-Fi. So when you think about it, this might be Cat 3, and this is Cat 5e or Cat 6. Now, if you upgrade from an analog phone to a digital phone, so an IP phone, this wiring will be useless. But on the other hand, if your phone system is near your network room and you ran everything in Cat 6, you could use your analog phone with your Cat 6 or your Cat 5e and then later switch out your analog phones to IP phones and keep the same cabling, which has happened a lot. And now, of course, we have a lot of people using the daisy chaining. Now, it's very important to think about if we're using IP phones, so we have redundant power, redundant internet, low latency. So that means maybe two internet connections, because we need to make sure our data is our phone system is in top shape. If we have any interruptions to our phone system, say in a hospital or something, to have some serious consequences. Obviously, can't use a IP system to monitor a fire alarm. It's not allowed. So, and I'm talking about there's two different kind of IP systems. So on your basic system, you got POTS, which is phone line coming in from the phone company, and you have a normal phone, analog phone, like one you buy from Staples. And you might have a bunch of these, daisy chain or whatever. And then you have a PBX. So you still have phone lines, but you might have multiple lines coming to a PBX. So these are still two pair or one pair. And the PBX connects to the different handset extensions with one pair. This is like a Nortel, Toshiba, Avaya, IP Office, Digital. And then you have kind of a like a PBX, but this is digital. You have PBX now with IP. So now this is like you still have phone lines coming in, but now you have it's like a Cisco call manager. So you still have a IP PBX, and you have handsets, but now everything connects to your network. So this is still so now here we're using Cat 6 or Cat 5e, and then we now coming into this era we now have the cloud. So with a cloud system we have no more phone lines, we just have handsets. So basically IP phones and IP adapters for fax machines and things. And these connect to our network. And this goes into the internet. So the voice line comes in digitally. So there's no more physical line. Should mention, in this case, we can also have a PRI, which is one pair that carries up to 23 lines. There's other situations. This can be we might have another office where we have our PBX, so we might have a LAN. So we might have an office or a data center or co-location. And then we may also get our lines over SIP. But basically, this device is hosted locally. So in all of these cases where you have a PBX or cloud, you have a single point of failure. And you want to eliminate that. And the way you do that is by always keeping one analog line from Staples. So you keep an analog line and an analog phone, or maybe 2 or 3. And this can be a backup phone. So you have a plus here. So this should always be part of your system. So backup, fax, alarm, fire, alarm. Now you always have 1 or 2 lines. So, and then I mean this can can't really connect to a cloud system, but it can connect to your IPPVX if you want to. I'd probably keep it separate, so we always have, or I keep it separate, plus I'd connect it, plus I'd have other devices connected to it directly. That way can use it in the event that the PRI or the SIP fails. You can switch over to this line, keep using your IP handsets, and if the PBX itself fails, you can't use your handsets anymore, but you can still have your backup. And that about covers as much as I need to cover on IP phones for the purpose of this talk. Any questions?